Hello everyone. Thank you for being here. So I'm here to talk to you about graph and how it will play a major role when it's put at the core of microservice architecture. But before I tell you anything about how that can help solve a major problem, I would like to reason with you about why in the first place you would be even considering microservices for your next product probably. But first I would like to know who of you have used microservices or is using microservices right now? Yeah, that's a good number. So you probably know why you're using microservices, but let's go through them very quickly. First, the first reason why you would consider microservices is so that you can have an effective teamwork. When it comes to teamwork and when it comes to development, you would want to remove everything that will come up and will not add any value to the actual product development. It's basically getting rid of all the impediments that you might face as you go through the development process. Things like code versioning and dependency resolution, everything that has to do with resolving the dependencies of your application. Working on the same code base for the whole product will introduce these kind of complexities. But with microservices, what we will have is isolation. We will have each service having its own infrastructure, having its own dependencies for itself, and its versions for itself as well. So that's the first reason. The second reason is scale on demand. To tell you about scale and how microservices changes that notion, I'll give you a small example about that. So let's say we have a typical e-commerce system where users can search for products, can discover products to buy, and at the same time they can also edit their accounts, manage their addresses, their cards, etc. Now if you look at these two aspects of a product, specifically in e-commerce, you would realize that when it comes to discovering and search, it is used much more than anything else. You won't change the address and your add cards and change your cards on a daily basis, but users will be searching a lot and they would want to discover a lot of products. So what you would want in such a system is to scale separately, to scale everything that has to do with product discovery, but keep everything that has to do with account management and user profile management to a very small resource, so that you do not have to, in the example of a monolith application, basically a monolith application is one code base that has all of your application in it. So if you were in a monolith example, if you were to scale the search, you will have to scale everything that has to do with account management with it, although you don't want that. But they are tied, and you will have to accompany everything that has to do with the infrastructure and the resources for all of your system. But with microservices, what you will have is one service that is completely responsible for everything that has to do with search and product discovery. Scale it, let's say you have 10 instances running, which is a small number, but just for the sake of the example, 10 instances running of product discovery, but just 2 for the account and everything that has to do with user management. So with microservices, you'll be able to scale separately and on demand. As you need it, you scale up. If you don't need it, you can scale that down, specific aspects and responsibilities of the product. One last reason I'll mention is resilience, specifically when something goes wrong, because things will go wrong at the end of the day. And when it does, you will want to find out what actually happened and where that thing happened as quick as possible. And given the separation and distributed nature of microservices, it makes it really easy to pin your finger on exactly where that thing occurred and work on that specifically. And when you do fix that thing, you will not have to deploy all of your code for all of the parts of the application on all of your infrastructure. It will only have to do with that specific service alone. And it will have its own versioning, so you wouldn't have to push a new version, maybe an upgrade or an update for your entire infrastructure, entire product, just because of this small thing. It will only have to do with that specific service. I hope you're convinced by now, because I would also like to mention that you should not rush jumping on the bandwagon. It is kind of a trend now, microservices. You hear the word everywhere. But I would like to mention that microservices is not for everything, for every kind of case, and it's not for every company, of course. Specifically, if they did not figure out whether they need microservices or not, because at some point you will be delving into a lot of complexity that I will talk about in the next slide. Specifically, if you did not figure out your tools, if you did not figure out the plans, the services that you need to use, and have all your tools ready to get into microservices. So speaking of these tools and the plans, here are some of the essentials when thinking of microservices and moving into them. The first thing and the most important aspect of services and microservices infrastructures is to know the composition of your services. What defines a service in your system? What makes a responsibility in your product? This is the first thing that you will start thinking about, which I bet you have already started. Now, if, let's say for the example, you have a monolith application already that you would want to transform into microservices. You've already started building this kind of a graph in your mind, separating services, separating features into their own kind of small, isolate, contained environments. And this needs to be thought through very well. But one thing to keep in mind is that this will change drastically over the scale of the product. It will never be the same as it started. So it has to be agile, it has to change with time. But you have to figure out at least what makes a service in your system and what actually should be a separate contained environment by itself. Moving on from there, you will need orchestration. When you first start, you would think that, okay, I have a couple of services, 2, 3, 4, maybe 5. That's manageable manually to deploy, to have everything that has to do with versioning and coding. You've separated teams as they should be and each working on their own responsibilities on each service. But at some point, this will be hard to maintain. There will be many more services in your cluster that you will have to manage. And this is where orchestration comes into play. Basically, orchestration is about having an automated way to look at your infrastructure and to control it. It's the back panel of your infrastructure to know which service is running now, which service isn't, to be able to launch new services with a press of a button, maybe with all the configurations that you might need. And that orchestration tool should also be adaptable to the changes of the product throughout the time. One other aspect is service discovery. These are very important 3 aspects. Service discovery has to do, is in other words, your internal DNS of your infrastructure. So services will communicate, that's for sure. But how do they communicate? How would they know how to get from a service A to a service B? How would I call service B if I do not have their IP addresses? So what can I do to have some kind of a resolution system inside my infrastructure of services? And this is service discovery. And there are many tools to do that. One of them is AWS Route 33, Console, etcd, and Zookeeper. These are very well tested tools that you can use already that provide all of these intricacies about service discovery and DNS resolution internally. One last essential I would like to mention is monitoring and logging. So imagine all of these services right now working in the background doing things and you being blocked out and not being able to see what they're actually doing and what is actually happening. If something goes wrong, you might know from a log file if you check it. And this is the kind of active monitoring. But what we're talking about here is at any point in time, you would want to look at your infrastructure and see what is actually happening, to know that this transaction went from A to Z without no interruptions. And maybe if there were interruptions, you would want to go back, troubleshoot, and have everything that has to do with logging there. And these are very important aspects when it comes to microservices, and they need to be centralized. When I speak about monitoring and logging, it's not just log files, and it's not the infrastructure that you monitor on a daily basis, like your Linux server to see the RAM and the CPU. Those are essential as well, but you need this kind of a dashboard that would tell you that your infrastructure is doing well and is working well, because there will be a lot of parts for you to monitor manually. So it needs to be centralized. This is actually the essentials, but even having all of this would still get us into we will still be hitting bottlenecks through the development of the product, and actually after the development process when we are online. One very important aspect which is crucial in product, which has to do with documentation. Let's say a new person joined our team who's responsible for the infrastructure now. How would we be able to describe that infrastructure? And how would we provide this kind of overview of how things are working and how things are connected? It will be very difficult to maintain with manually hand-drawn diagrams because these are not maintainable. Our infrastructure is changing day by day. There's new code being pushed, there's new features coming up, and there's new versions being deployed, and there's so many things happening at the same time that we won't be able to maintain manually. So we would want something, a tool, a technology, to provide this kind of feedback about our infrastructure. It needs to know everything and everything that's happening. This kind of tool needs to be flexible because there's a lot of changes. As I mentioned at the beginning, our system will look completely different in a month from the start point. It won't be the same at all. So this tool needs to be flexible, to be bendable. We need to change a lot through time. And at the same time, we need performance. Because there's, again, a lot of things happening at the same time, and we would want to look at everything in real time. So performance is one crucial aspect. If only there was this kind of tool that is flexible enough and would perform at scale with a large number of records, a large number of data. But I guess this is why we're here today, right? Because we have this kind of tool, and it's the graph database. And this is how we can use that to solve that major problem. So, as I mentioned earlier about the infrastructure, it would start with a couple of services maybe. For this example, I'm going to use AWS as our example. AWS is the provider of hosting solutions, so you can, I bet you all know AWS. There's no description required. ECS is one service that is provided by AWS, and what it means is Elastic Container Service. Basically, it provides all of the essentials that I've mentioned earlier in different services. That has to do with monitoring and seeing how your infrastructure is laid out. In coordination with EC2, which is what manages your servers, and to be able to see all your instances that host those services of yours, EC2 will help. But the problem with that is that it displays them in a tabular form. It will show you these information that you would like to know, but what you will be able to see is not exactly all the information that you need at a certain point in time. What you need to know is how these services are communicating and whether things are working fine or not. And also, in a tabular form like this, it's not, you cannot see relationships between these services. You see them separately, individually, but what's the connection, right? And this is where graph comes into play, because as we add more services, if you look at this, you see the gap between how things are currently in AWS and how things are displayed and how they should be and how things are in reality. Services and the infrastructure is all a big graph of machines working and doing things together. And this is what we wanted to do. In addition to that, the services that you see are also, in AWS specifically, in the ECS service, are clustered, are grouped in logical clusters together. That's up to you and how you organize those, but it must live in a certain cluster, which makes it even harder for you to figure out where to go and which service is living in which cluster. To keep that information in your head is really a challenge. And this is why we needed something in the middle, something that would communicate with AWS to get all the information about our services, but put them in a more natural form of how they actually live in your infrastructure. And that way, we've closed the gap between the information there on AWS and how we see things. And now we can build relationships between these services that would describe how they actually communicate and what they exchange, what kind of data, and everything that has to do with what's being transacted between these services. I would like to conclude by saying that when it comes to DevOps, this is mostly DevOps work. This is infrastructure, this is system administration. And when we think about DevOps and system administration, we think of these people behind black screens working on these commands and just carrying and worrying about the infrastructure and servers. But with this kind of tool introduced for DevOps, we would be bringing a new opportunity for them to open up on a new kind of knowledge, a new way to explore the infrastructure. Once we have it in Graph, we will be able to query our infrastructure, and this is something that is really tough to do when it comes to the kind of relational tabular form of record keeping. And from there, I would say that DevOps need to be able to explore these kinds of possibilities and to advance their kinds of skills and be able to query the way we do with applications, to query the infrastructure as well, because it is what runs our applications. Thank you. Any questions?
So, is it only another representation of the information which are already exist in Amazon?
And you can add up to them, because you will have your own version of those. So you'll get the information that you need from the AWS, and you add up to it by saying what these services do, what they exchange, and what kind of data is there between them, and whether it's working properly or not, their status.
But yet the other information which are on Amazon you get for free.
Mm-hmm.
You add your
It's through an API, it's open.
Right.
Yes. Yeah. Yes.
Do you have a feature for predicting failures? So you see that this link is saturating, there might be an issue here?
Exactly. That's something that we're working on currently, actually, to have an agent sitting and monitoring your network all the time and trying to predict based on the data that you have. Yeah. Now that you have this data in your graph, you can start analyzing and predicting, as you're saying, to know that as long as this is happening, there's something wrong. It's going to happen at this point, at this time, maybe with this service around the network, probably. So it will be these agents reporting back to your dashboard, and dashboard will be doing its own kind of analysis about everything that's happening in the infrastructure.
That's great.
Yeah.
One question.
Sure.
Thank you. So my question is, in some microservices implementation, the message systems or queue systems are used. So would you such think it's, am I right if I say Jenkins? I'm not sure. But do you suggest that you replace those messaging systems with Neo4j, or you use them in parallel?
I like to think of queue systems as a transit point. They make sure that the data that you send in them is sent to whoever needs to receive it. But you would treat it as a service itself. You have a service called queue, maybe RabbitMQ, maybe some other kind of service that you use for queuing. You would think of it as a service by itself. And even that can be exposed by another service through an API or anything that you have in between. But yes, you will be treating it as a service, but not replacing it at all. Right? A question back there?
Yeah, one last one.
Yeah, okay.
Can you hear me without mic?
I can, yeah.
It seems to me that one of the hardest things is knowing who's talking to who.
Hello. It seems to me that one of the hardest things is knowing who's talking to whom.
Exactly.
And being right about that. Do you have any suggestions, any kind of how you figure that out, other than the developers kind of announcing it? Is there any way of actually verifying it? You know.
Yeah, actually, what you're looking to find is some kind of an active reporting about what service is talking to what other service. And for that to be solved, you will have to sit at the medium they use to communicate, and not them, which is what the developers do. And the medium they use is the network, which is where they live. And this is what we do. We put an agent on the server that monitors that network, the interfaces of these networks, and monitors where these communications are going, because you have it contained, you have your DNS inside, so you know which service is being called at this moment. You know what data packets are being sent. So it is pretty easy to know which service is communicating with which other service, and you can go really deep with the services that are actually communicating. Like if you have a web server with the application on separate containers, you'll be able to know which part of your system is communicating even. And that is more of an infrastructure thing than a development thing. So yes, you will have to do that on an infrastructure level through agents monitoring the devices of your network. Sure. That's it. All right, thank you.